Welcome back, everybody. In this Python tutorial, we're going to go over the Seaborn library. Seaborn is a library for making statistical graphics in Python. It is built on top of Matplotlib and closely integrated with pandas data structures. Matplotlib can be used to add to or change Seaborn plots. For the imports, we're going to use pandas, numpy, Seaborn, Matplotlib, Vega datasets, and PyDataset. For the datasets, we're going to use Vega datasets, PyDataset, and the Seaborn datasets. To load a Seaborn dataset, you can use seaborn.loadDataset and put in the type of data you would like to use. The first types of plots we're going to go over are relational plots, the first being the relplot. Now, for each type of plot, such as the relational plots, usually there is a figure-level interface for drawing plots onto a FacetGrid. And these types of plots allow you to split and organize the data and show details in different ways. And we'll go over examples of that. For our first example, we're going to use the cars dataset. And we're going to use this code here. This is a basic relplot, which is going to show us a relationship between data elements. So we use seaborn.relplot. We put in the x and y data and the name of the data set. The kind for this example is going to be scatter. You can also use line. So this just shows us a basic scatter plot, which shows us the relationship between weight in pounds of a car and the miles per gallon. Now, as we mentioned, this is a figure-level interface for drawing relational plots onto a FacetGrid, which means we can do a lot more than just create a simple plot. And here we have an example of that. We put in our x and y data, and in this case, we're going to split the columns out by cylinders. So you can see here we have cylinders 3, 4, 5, 6, and 8. And we're going to split the rows out by origin. So the first row is the USA, the second row is Europe, and the third row is Japan. And this example gives us scatterplots showing relationships between the data in different ways. Here we have another example, and in this case, we're going to show years using column wrap and origin using the hue color. On the x-axis, we have the weight in pounds. On the y-axis, we have the miles per gallon. Now notice for the hue or the color, we have assigned origin. The USA is blue, Europe is orange, and Japan is green. Now for the column, we have assigned year. So here, for the columns, we have the years, and they are wrapped after 4. Okay? Here's another relplot example. For the x-axis, we have the weight in pounds. For the y-axis, we have the miles per gallon, and you can see that it's split out by origin. And for that, we assign origin to the column. Now, another thing we have done is we have rescaled the sizes, and that will adjust the sizes of the bubbles. And for the size argument, now notice that's different from the sizes, we have assigned the horsepower, and you can see the legend for that here. For the next example, we're going to use the Gapminder dataset. And in this case, instead of using a scatterplot, we're going to use the kind of line. So we get a line plot, and for the x-axis, we have the year. And for the y-axis, we have the life expectancy. We have separated the columns by country, and we're going to wrap after every 8th column. So this shows us the trend for life expectancy as time passes for each country. Moving on, here we have the Seaborn scatterplot. For this example, we're going to use the diamonds dataset, and we want to see the relationship between the diamond carats and the diamond prices. So all we have to do is put in the x and y data and the diamonds dataset. For the next example, we're going to use the tips dataset. And in this case, we want to see the relationship between the total bill and the tip. Once again, we have used the size and sizes arguments. The sizes will rescale the data. And for the size argument, we're going to use the size column. And this is the size of the party or the number of customers for each bill. And notice you can see the size legend here. Here, we have a scatterplot example where we use a special color palette. Now a quick note, If you want to reverse a color palette, you can use a _R. If you would like to darken a color palette, you can use a _D. And to create the palette, we use this code here. For this scatterplot example, we use style, and we assign time. So the X's would be dinner, and the dots would be lunch. And here we have one last scatterplot example where we have used Matplotlib arguments, and we're using a different way to pass in the data. So instead of using the quotes in the data set, we just go ahead and reference the data frame, and then we use a dot and we access the column. And here we have used some Matplotlib arguments. Next, let's go over some examples of line plots. We're going to use the Seattle weather dataset. And in this example, we have the dates on the x-axis and the precipitation on the y-axis. Now notice that we've used some Matplotlib syntax. We've gone ahead and created our figure and our plot with the fig size of 10 by 5. Then here we use the Seaborn line plot to pass in the data. And make sure when you create a figure and an axis plot that you assign that to the ax argument. The next example is basically the same. However, we have aggregated the data by month. Okay, so often in Seaborn, a default behavior is to show the data as an aggregate. And in these cases, you want to pay special attention to the estimator and the confidence interval arguments. So let's go over some examples of the CI and estimator arguments. We're going to go ahead and use the San Francisco temperature dataset. And here we have created 4 examples. And what we want to do is to show the date on the x-axis and the temperature on the y-axis. So this is just going to show us the temperature as time passes. Now, for the first example, we use a confidence interval of 95. For the second example, we're going to use the standard deviation for the confidence interval. For the third example, the confidence interval is none. And for the fourth example, we set the estimator to none. And here we have visual representations for each of those 4 examples. Here we have the confidence interval of 95. Here we have the standard deviation. Here the confidence interval is none. And here, the estimator is none. Okay, just a few more details on the estimator and the confidence interval. The estimator is the method for aggregating across multiple observations of the y variable at the same x level. If none, all observations will be drawn. And here we have some examples. Typically, you can use the mean or the median. The CI, or the confidence interval, is the size of the confidence interval to draw when aggregating with an estimator. For the next example, we're going to use the sleep study data. Now in this example, we want to use the hue or color to plot subjects as separate lines. So we go ahead and pass in the data, and then we assign subject to the hue. And this is the result. Now if we take that out, we go ahead and we get one line, which is the aggregation of the data, and then you can see the light blue shaded envelope around the line is the confidence interval. Next, we have a few more examples of simple ways that you can create line plots. Now one way is to just go ahead and pass in your data to the line plot. And then you can do it again, and it will plot the data onto the same plot. Another way you can do it is to take your data set and make the dates an index. And then you can just go ahead and pass in your data. Okay? So you can see that this plot using this way and this plot using this way gives us the same results. And then here we have one more line plot example where we want to see only parts of the data. To do that, we go ahead and create our data, where we use the dataframe.loc, and then we pass in the rows that we want and the columns that we want. And then we do the same thing again. Now notice for the blue line, which is A, we're showing all the data. For the orange line, which is B, here, we are only showing part of the data. And that's because for the rows, we started on January 5th. Next, let's go over some examples of categorical plots. For the first example, we're going to use the arthritis dataset. And the first categorical plot type, we're going to use the catplot. And the catplot is a figure-level interface for drawing categorical plots onto a FacetGrid. And this is one of those types of plots where you can split the data into rows and columns and show different levels of detail. And for this example, we're going to use the kind of count. So we go ahead and pass in improved for X, and we want to split the columns by the type of treatment. So here we have treated, and here we have placebo. And then we get the counts by the levels of improvement, which are some, none, and marked. So for the placebo group, the highest count is in none, which is what we would expect. For the treated group, the highest count is in marked. Also, that's what we would expect. Next, let's go over an example of the strip plot. The strip plot draws a scatter plot where one of the variables is categorical. Let's go ahead and use the cars dataset. Then we pass in the X data, which is the origin, the Y data, which is the miles per gallon, and then pay special attention to the jitter argument. The jitter argument offsets points so they don't overlap. This makes it easier to see the distribution of the data. Now, if we set the jitter to false, you can see that the points stay in a straight line. Another plot, very similar to the strip plot, which is called the swarmplot, creates a plot that's very similar. However, it has no overlap in the points. And we'll go over an example of that here in just a second. Now here we have another example of the strip plot. However, in this case, we have separated out the cylinders by color. And another way that you could separate the data is to set the dodge to true. And the dodge will separate the hue colors into their own clusters, like this. So here we have the swarm plot. The swarm plot draws a categorical scatter plot with non-overlapping points. Now, as we mentioned, the swarm plot is similar to the strip plot, but the points don't overlap, and this can give a better representation of the distribution of the values. Another note, if you wanted to change the order of the categories, you could do that with the order argument. Next, we have an example of the boxplot. The boxplot shows distributions with respect to categories. And it shows the minimum, the maximum, the median, the 25th percentile, the 75th percentile, and the outliers. Here we have an example of a boxplot showing the different distributions of the iris dataset. Another thing you can do is you can overlay a strip plot or a swarm plot on top of a boxplot. And this just helps show additional information about the distribution of the data. Here's another boxplot example using the cars dataset. Next, we have an example of the violinplot. The violinplot is a combination of a boxplot and a kernel density estimate. A kernel density estimate is closely related to a histogram, which shows you information about the distribution of the data. Okay, so here in the middle we have the boxplot, and the boxplot is wrapped in the KDE plot, with the KDE plot turned on its side. Here we have an example of the boxenplot, and basically the boxenplot is a fancy boxplot. Next, let's go over an example of the pointplot. Pointplots can be especially useful when you want to make comparisons. We're going to use the tips dataset, and we want to compare the average total bill for lunch versus dinner. So here and here we have the average total bills. This is the average total bill for lunch, This is the average total bill for dinner. These bars here with the caps are the error bars. And this line here shows us the slope for the comparison. So we can see that the average total bill for lunch is quite a bit lower than the average total bill for dinner. Let's go over an example of a bar plot. We're going to use the Seattle weather dataset, and for this example, we want to see the average precipitation by year with the error bar. If you wanted to get rid of the error bar, you can set the confidence interval to none, like that. For the next example, we have the count plot. Now the count plot is somewhat similar to the bar plot. However, we're just going to see the counts. Notice in this case, we're showing an average. And in this case, we just have the counts. So we're going to use the arthritis dataset, and we just want to see the counts by levels of improvement. And you can see that here. Next, let's go over the distribution plots. The first example is the distplot. We're going to go ahead and use the trees dataset. If we use the distplot with the tree's height and the rug and KDE are true, this will give us the histogram, which shows us the distribution of the data, the kernel density estimate, which is basically like a smoothed out histogram, and the rug plot, which gives us additional information about the distribution of the data. Next, we have the KDE plot. And the KDE plot is showing us the distribution of the data, just like in the last example, however, in this case, with just the kernel density estimate, which, as we mentioned, is similar to a smoothed out histogram. For the next example, we're going to use the earthquakes data. And this data is from Kaggle. So here we are using a KDE plot with two variables, along with cartopy. And this is going to show us the distributions of earthquakes around the world. So this is one way that you could use a two-variable KDE plot with contours, along with a cartopy map. So here we have the rug plot, which we showed an example of earlier. However, if you wanted to create a KDE plot with a rug plot, you could go ahead and create the KDE plot and then create a rug plot. And once again, the rug plot plots data points in an array as sticks on an axis. And this helps show additional information about how the data is distributed. Next, let's go over regression plots. For the first example, we have the lmplot. And this is one of those types of plots that you can use with a FacetGrid, which means you can split it out in different ways to show extra levels of detail. We're going to use the Cars 93 dataset, and here we want to show the relationship between the engine size and the horsepower, along with the regression line. Now notice we've split the columns out by the drivetrain. So here we have the front and the rear and the four-wheel drive. And you'll notice as the engine size increases, so does the horsepower. And that seems to be the case most with the front drivetrain. It's still the case for the rear and the four-wheel drive, but less so for the rear. The next plot type is the regplot, which allows us to plot data with a linear regression model fit. For this example, we're going to use some speed and distance data, and this data contains car speeds and the corresponding distances needed to stop at those speeds. Okay, so to create a regression plot, we go ahead and pass in the data, and in this case, we've set the confidence interval to 68. And for the plot, we get just what we would expect. The faster the speed, the more distance it takes to stop. And here we have the regression line, and the light blue envelope around the regression line shows us the confidence interval. Now if we change that to 95, you're going to see that the envelope will get bigger, like this. Next, we have an example of the residplot. and this plots the residuals of a linear regression. The residual is the difference between the predicted and the actual values. A residual plot can be a good way to examine a model and determine if changes need to be made. Next, let's go over matrix plots. The first example is a heat map. We're going to use the cars dataset, and we're going to create a correlation matrix. To create the heat map, we're going to use seaborn.heatmap. Now notice, for the heat map, we're using the correlation function. And this will give us a heat map that shows us the correlation between the different data elements. The darker the red, the higher the positive correlation. The darker the blue, the higher the negative correlation. So for example, if we look at miles per gallon, compared to the weight in pounds, it has a high negative correlation, which means that the heavier the car, the less miles per gallon you're going to get. Next, we have another heat map example, and for this, we're going to use the Seattle weather dataset, and we're going to pivot the dataset so it's in this form, which shows us the temperature max by month and year. Then we can take this dataset and pass it into the heat map. And this heat map will show us Seattle temperatures by month and year. Next, we have the cluster map. A cluster map is a combination of a heat map and a dendrogram. A dendrogram is a tree-shaped graph that clusters more similar variables under the same branches. So basically, we're going to take this heat map here and cluster the similar variables together. Okay? And you can see the outcome of that here. So here we have the warmer temperatures clustered together. Here we have the more moderate temperatures clustered together. And then here we have the colder temperatures clustered together. You can see the branches of the dendrogram here. Next, let's go over some examples of multi-plot grids. For the first example, we're going to use the exercise dataset. And we're going to create a FacetGrid. We have passed in the exercise data, and we split the columns by kind. So the first column is rest, the second is walking, and the third is running. And we split the row by diet. So the first row is no fat, and the second row is low fat. Then we use map to map a histogram to each of the grids in the FacetGrid. And this is going to create a histogram using the pulse data. For this example, we're going to create a pairplot using the cars dataset. When we create the pairplot, we get a whole bunch of scatterplots on the upper triangle here and the lower triangle here. On the diagonal, we get our KDE. The pairplot is a quick and easy way to see distributions and relationships between data elements. Next, we're going to go over an example of the PairGrid using the iris data set. And you can see that this gives us scatter plots showing the relationships between the petal length, petal width, sepal length, and sepal width. And we have the species split out by color. And you can do that by assigning species to the hue. Then we use map to plot the scatter plots onto the grids for the PairGrid. Next, here we've gone ahead and created another PairGrid. However, in this case, we've used the map diagonal and the map off diagonal. For the diagonal, we have plotted histograms. And you can see those here on the diagonal. For the off diagonal, we have used scatterplots. And that will put the scatterplots on the grids that are not diagonal in the upper and lower triangles. For this example, we have created a pairplot, and then we're going to use map lower and map upper to map and plot a function onto the pairplot. Here we have gone ahead and created a correlation function that will help us to plot the correlation coefficient onto our pairplot. And to put the correlation coefficient onto the pairplot, we go ahead and use map lower and map upper, and put the function inside the round brackets. And you can see we have our correlation coefficient on the upper triangle and the lower triangle here. Next, let's go over the joint plot. For this example, we're going to use the housing dataset, and the joint plot is a cool way to combine plots. We have created a hex bin plot that shows us the relationship between the lot size and the price of the house. Hex-bin plots can be a good replacement for scatterplots when the scatterplot points overlap and there's too many points to tell what's going on. So here we're showing the relationship between the lot size and the price using the hex-bin plot, and here on the edges, we're showing the distributions of the data using histograms and rug plots. Here we have another example of a joint plot created using a JointGrid. To create this joint plot, we go ahead and pass in the data, and then we use plot. For the main plot, we're using a regression plot, which is a scatter plot with a regression line. And this shows us the relationship between the lot size and the price. For the second plot, we're going to use the distplot, and these are the plots you see on the edges, showing us the distribution of the data, using the histogram and KDE. And finally, we have one last example. Here we have created a joint grid. And then we use plot joint to create the scatter plot. Here, we use plot joint again to create the KDE plot with two variables. Here, and then we use plot marginals to create the KDE plots on the edges. That's all we have for this tutorial. Join us again next time.